Welcome to this edition of Fuel for Thought. I'm Kristen Balasia, Vice President of Consulting Services at S&P Global Mobility. I'm pleased to be joined today by my colleagues, Hwang, Senior Research Analyst, and Anoop Desai, Director, Consulting Services. We're going to be discussing a really hot topic today, the battery supply situation. Good morning, gentlemen.
Thanks a lot for having us, Kristen.
Thanks for having us, Kristen. Good morning.
Good morning. So we're finally seeing the commitment and growth of EVs by automakers, governments, and even consumers coming to fruition, with retail electrification market share at almost 13% in the US in April of this year, and pure battery electric hitting 5% on its own. And again, seeing almost all of the major OEMs making significant volume announcements. It's really exciting to see. It's great to be out in the market and see these new exciting products to talk to the OEMs about. But this begs the next question. Do we have enough global raw material supply to support all of these stated aspirations? So Jay, why don't we start with you and answer that first question of how quickly will the electric vehicle market grow in the next decade? And why or what kinds of issues is this going to cause with battery raw material likely?
Yeah, Kristen, that's a great question. And to touch on electric vehicle demand side, the EV demand will exponentially increase roughly about 10 times for the next decade, from around 5 million units in 21 to more than 50 million in 2034. So that's what's going to happen in the demand side of the equation. But if you look at the supply side of the equation, it's hard to increase the battery metal mining supply dramatically, especially within 3 to 5 years time frame, since typical battery metal mines require more than 5 years to begin operations in case of greenfield projects. So it's a really complicated projects, which involves site exploration, feasibility study, regulatory approval, construction, and the commercial operation. So it's not that easy to increase the supply dramatically, especially in the battery metal side. So that's where the problem lies in.
Yeah, absolutely. And I think not only are you right, but the OEMs are realizing this and, out there trying to figure out what to do about it. So Anoop, how are the OEMs? What are we seeing? What are we hearing in regards to what are they doing to currently navigate this situation and this concern? And do we think they're doing enough and fast enough?
So are they doing it enough and fast enough? Clearly not. But it's interesting how OEMs have kind of pivoted themselves. So if we were to look 5 years ago, everyone kept asking, hey, who is going to buy electric cars? And all of a sudden, everyone is buying electric cars. And now we are running into supply situation. So the tables have turned clearly, and OEMs as well are looking into different ways of doing it. On one extent, we do see that they are trying to do vertical integration, building partnerships with key battery pack manufacturers, cell manufacturers, and so on. The vertical integration is a new buzz out there. But in addition to that, what we are also seeing right now is OEMs actually going very deep down into the value chain, into the metals and mining space as well. And this is a new announcement, a new strategic initiative OEMs are taking up. Again, it's a pan industry wide. If you were to ask, are OEMs doing enough? Probably not. But there are a few OEMs who are doing relatively well in this space, and this momentum is going to accelerate in the times to come. So interesting times ahead, I must say.
For sure. And the way you started, it made me think of that saying, be careful what you wish for, right? All of the
Exactly.
OEMs want everyone to come out and buy these EVs, and they are. And then, yeah, it breeds a whole other group of problems. So you talked about materials, and Jay, why don't we go to you? So within, the list of the key battery raw materials, what are the most critical components that could disrupt the whole EV and battery supply chain?
Yeah, I would say nickel, cobalt, and lithium. Those are three critical battery metals, which may become bottlenecks within battery supply chain. And if I walk through a little bit about how much volume in terms of kilograms uh, of nickel and cobalt included in the battery pack, typically the battery pack within the electric vehicle weighs more than 500 kilograms. And within that, the percentage of nickel and cobalt weight is very small, like 10% or less than 10%, respectively, for the typical and nickel, cobalt, manganese battery cell. So that's about the weight percentage. However, is critical component within the battery. Um, so uh, so there's there's a potential supply shortage, like I mentioned in the first part. But for these metals, this potential supply shortage have been evidenced by recent battery metals price volatilities. So, for example, according to S&P Capital IQ data, the nickel price hiked by 150% in March 2022 peak, 2 weeks after the Russian invasion of Ukraine, and then came down to the normal level. And cobalt price has been hiked up 60% or so in March peak and then came down. So there are a lot of huge volatility in nickel and cobalt, which is evidenced by the price volatilities. And lithium is still trading at a high level because as you can see from the name of the lithium ion battery, it's a critical component and irreplaceable component within the lithium ion battery. So lithium price has been up by more than 600% or so from a year ago, and still stays at that level.
Yeah, and I think that's leads to my next question about, what can they do about it? So certainly there's the price volatility, which, I mean, when you talk about things like 150% or 60%, that's really difficult to forecast. That's really difficult to prepare for, and really work through. So, Anoop, is there anything that we don't currently see in the market but has a potential to address the raw material shortage and maybe provide some alternatives?
Absolutely, Kristen. I think there are some. This is a cross-industry topic, right? Batteries are not just used in automotive vehicles. Batteries were used in smartphones, have been used in energy storage devices, and so on. So when we look at what's happening across, there could be some breakthroughs that can potentially come in. So just as an example, even when we are looking into automotive batteries, the cell chemistry of LFP is not something that we saw as gaining major acceptance even 3-4 years ago. But now we are seeing that more and more OEMs are focusing towards that technology. So again, reiterates the fact that things are going to change and they're going to change quick in this domain. So is there something that we clearly do not see right now? Probably yes. There are some new age technology solutions that are being spoken of. First of all, we need to understand the economics behind it. Is that going to be a solution that we can fit into mass market passenger vehicles, or is it going to be applicable to niche vehicles such as the high-end luxury sports performance vehicles, or is it something that we can actually think of being installed into vehicles that Volkswagen, Ford, and so on produce? So that's one of the first things. Economics is something to be evaluated. And then comes the next element of the technology capability itself. We are seeing some announcements coming in from suppliers where they're talking about sodium battery packs. This is something that's more of a hot topic right now. But again, the technology is still not entirely proven. It's still in a nascent stage. So it's going to be interesting times ahead when it comes to the new chemistries and technologies that would come into the market. We are monitoring it quite closely, closer than ever before. And I think we'll monitor it even more closer in the times to come.
Jay, what's your perspective on that? Do you have anything to add and how difficult you believe it's going to be to replace, the likes of nickel and cobalt?
Yeah, I can maybe touch on how battery makers respond to this challenge. So currently, LFP is led by Chinese battery makers such as CATL and BYD, and this is adopted in more entry-level electric vehicle models, as Anoop mentioned, such as Tesla Model 3 standard range model, for example. But there are a lot of efforts from the battery makers to make a transition from nickel cobalt manganese or nickel cobalt aluminum, which contains high amount of nickel and cobalt, to the nickel and cobalt free chemistry of LFP. So um, adding to that, battery makers are doing a lot of research on high manganese, nickel cobalt manganese to replace or minimize cobalt usage to avoid high price, and also to touch on a little bit about the ESG perspective, child labor issues related to cobalt mining in Republic of Congo. So those are something that battery makers are really working hard to do.
Absolutely. And you mentioned ESG. So in light of growing demand for ESG really in all industries, can you talk about some of the ESG efforts that the battery upstream aims to achieve?
Yeah, sure. In terms of ESG, I think the focus of vehicle makers seems to be on zero emission vehicle and the zero emission factory. And the focus of battery makers seems to be also on zero emission battery facilities with solar panels, for example, and batteries with sustainable materials and recycling, etc. But in mining, it requires some breakthrough technologies to achieve the high level of sustainability. So among many efforts to secure domestic battery metal productions and sustainability perspective, advanced lithium mining with sustainability has been actively researched in the US. So a company called Control Thermal Resources, CTR, started its drilling program at Hell's Kitchen Lithium and Power Project in California back in November 2021. And they're also developing uh, a novel extraction technology called direct lithium extraction, and they try to use geothermal energy to achieve a zero emission. So I think that's going to be a potential breakthrough in lithium mining and mining industry overall. And General Motors and battery manufacturer Statevolt are major electric vehicle customers who agreed to procure volumes from this project.
And another area, so I mean, ESG, I think we're hitting a lot of the buzzwords, right? Battery supply chain, EVs, ESG. The other topic that's coming up quite a bit is battery recycling, right? To support the raw material supply. So Anoop, can you talk a little bit about the announcements, the technology, the capability, kind of the feasibility of this as one part of the solution as well?
Yeah, absolutely, Kristen. I think recycling is something that even OEMs are discussing more on. You have Redwood and so on, companies which are also closely collaborating with OEMs in the recent times. It's going to be an interesting space to watch, but the time frame that we are looking at into the forecast until end of the decade, recycling is not going to be that major of a topic, given that the demand for the recycled batteries is not going to be that high. Meaning to say that the incoming feedstock into the recycling plant is not going to be high, because the vehicles which are going to come for recycling in 2030 are still going to be vehicles which probably were sold in 2015 or so. So expecting an average range of about 15 years before a vehicle goes into the recycling lot. And with that kind of a momentum, the battery demand and the answers to raw material supply is not going to be that supportive, but it is going to be a very important aspect and topic that every OEM and supplier is going to be monitoring on. There is going to be circular economy benefits as well involved in there. The ESG concerns as well to some extent can be answered. You do not need to get more virgin stock into new vehicles. So this is definitely something that's going to be that's going to play a crucial role from a strategic relevance. However, when it comes to addressing the raw material supply itself, it's not going to play that vital a role, at least until end of this decade. So, but again,
Right.
lot of moving parts. So let's monitor this one.
Right. So we have to figure out the short term, medium term, and long term, and it looks like there's a few things along the way that are being investigated and invested in. So, final question for both of you. What are some things the industry should be doing, or maybe should be doing more of, or faster that you don't see, in your opinion? If you had a magic wand and you said, whether it's the OEMs, the raw material suppliers, um, what could we be doing, maybe creatively, that we're not doing enough of right now? Who wants to start? Actually, Jay, I'll let you start.
Yeah, sure, I can do first. So we think the potential supply bottleneck in battery upstream may occur due to its inflexible nature of volume ramp up. Like I mentioned before, it takes a lot of time to build a new mine in battery metal. However, we think EV demand and production volume will follow the hockey stick curve pattern, since the battery upstream shortage is a very well-known risk that has been handled very well by automakers and battery makers. So automakers try to secure the battery metal volumes, like Anoop mentioned, and battery makers work their ways to diversify their battery product portfolios to minimize the impact from the key metals. But I would like to highlight that refining facilities for intermediate materials is a potential risk that is not well known yet. So we try to keep track of that as well. And there's a huge geographical concentration in China, around 9% or so in lithium refining process, for example. So those are something that we try to track on closely. And for the US, I think it's positive that both public and private entities are well aware of the urgency of establishing domestic battery supply chain, but achieving it with meeting all the ESG standards is another challenge for them. So our battery team at S&P Global Mobility and Supply Chain Technology Group is working extensively on battery raw material subject, which will be published in a month or two. So please stay tuned for that.
Great, thanks. Anoop, your thoughts?
Yep, sure, Kristen. So I think one suggestion that we are telling all of our customers also is on the risk mitigation strategy. The world that we live in is changing dramatically, and in the current times, we need to plan more and more with scenarios, more and more with contingencies, and that's something I think we need to be prepared of, especially when it comes to battery topics. Having different suppliers on your portfolio who are going to be able to give you not just the same battery packs, but also with different chemistries, with different modes of operation. So this kind of gives OEMs as well the flexibility to actually shift their choices in the event of sudden price spikes and so on. So we kind of see that with what happened with Tesla as well, the shift into LFP, and all of a sudden LFP battery packs started making huge amount of volumes. Of course, even they're not immune to price spikes, but the flexibility is going to be the key, and I think working with contingencies is something that we highly recommend in the times to come in the current environment.
Absolutely. So I think we'll leave it there. And I want to say thank you to Jay Hwang and Anoop Desai. I think what's clear is, creativity and flexibility is going to be key. And we could probably talk about this topic, every other month, and something new would be, relevant and interesting to talk about. So again, thank you for your time, and thank you everyone else for joining us today. We'll be back with more Fuel for Thought next month. To opt in to our newsletter that provides more information on this topic and others, please visit spglobal.com/mobility.